So today we're going to cover Chapter 5, Section 3, Part 2. Okay, so in the first video, which was posted day prior, we did 1 through 7, and then in this video, we're going to be doing slides 8 through 12. So in this video, we're going to focus on what we call reference angles. So what happens is, if you have a calculator, you're going to be able to find the sine or cosine of any number, and you're going to get it in a decimal form, which we don't really consider exact. Obviously, we need a fraction or a whole number or a simplified radical to be an exact answer. And so we want you to be able to utilize what you know about special right triangles to find reference angles. And these reference angles will work with basically the 30 and the 60-90 triangles. So it'll have to do with 30, 60, and 45 degrees. And we'll talk a little bit about that. But if you were just to start and go to your calculator, and you were to insert in your calculator and say, okay, well, what is the sine of 30 degrees? Your calculator will give you 0.5, okay? If you ask your calculator or you type in what is the sine of 150 degrees, you're going to see you also get 0.5. If you ask your calculator what is the sine of 210, you're going to see that you get negative 0.5. And if you go into your calculator and you ask it what is the sine of 330 degrees, you're also going to see that you get negative 0.5. And so you start to realize, well, there's a relationship here with these numbers, because how is it possible that these 4 different degrees, and there's actually an infinite number that will give you this sine of a half or 0.5, because your calculator gives you decimals, okay? So you're like, okay, well, how does that happen? Well, first of all, let's talk about those angles. Let's look at those angles. I mean, a 30-degree angle, okay, is going to be an angle in the first quadrant that looks like that, okay? A 150-degree angle is going to be an angle that extends 90 degrees, and then it goes another 60, and it will end somewhere over here in quadrant 2. And this little piece of the angle left over from there to there, right, is going to be 30 degrees, because it's going to be about, let me kind of do it this way, from the x-axis to the terminal side, there's 30 degrees left. This angle itself is 150. 150 plus 30 is 180, which makes sense, right? And if I go to the other angle there, if I go to 210 and I draw that, again, I start here and I go 90, 180, and if I go 30 more, I realize that this blue terminal side is angle 210 degrees. And I notice that that terminal side, if I draw this line from or to the x-axis, this is also 30 degrees. And so you might start seeing this pattern that even though the degree measure is 210 degrees, it's 30 degrees from the x-axis. The 150-degree angle, yes, it's 150 degrees, but it's 30 degrees from the x-axis. The original angle we drew is 30 degrees from the x-axis. And you can probably guess that if I draw this last 330-degree angle, again, 90, 180, 270, and to get to 330, I've got to go 60 more degrees here to get to this 330-degree angle, and you realize that from here to here is another 30 degrees. And so what happens is that reference angles are the acute angle, that is the distance between the angle given, or we could say the terminal side of the angle given, to the x-axis. So for all of these angles, okay, the reference angle is basically 30 degrees. And that's why, and so what we're doing is really we're finding the sine of that reference angle. Okay, it's going to be equal. So the sine of 30 is 0.5. The sine of 150 degrees is going to equal the sine of its reference angle, which is 30 degrees. The sine of 210 here, the sine of this blue line here, let me kind of keep the colors the same, the sine of this blue angle 210 is going to be equal to the sine of its reference angle. So it's also going to be equal to the sine of 30. And 330, when we drew our arch and we got to this terminal side here, the sine of 330 degrees is going to be equal to the sine of its reference angle, which is 30. So how can we find our reference angles? Well, we can draw the angle given, and then we can identify how many degrees away is that angle from the x-axis. So you basically find the distance to the x-axis each time, okay? And that will help you. Or you can use a formula. I prefer to just visualize it, okay? And then just figure out how many degrees away from the x-axis it is. However, if you prefer to not do that, then what you can do is you can use the formula and you can memorize them. So in quadrant 1, the formula is the reference angles equals the angle given. So if I ask you for the sine of 30, the reference angle is just 30 degrees, okay? So it's the same. When I get into quadrant 2, it says that the reference angle equals 180 minus the angle they gave you. So for example, this is quadrant 2. If they gave me 150, the reference angle is 180 minus 150, which is 30, okay? That's how we got the 30. If my terminal side ends in quadrant 3, right, and I want the sine of 210, well, sine of 210, 210 degrees ends in this quadrant, I know the reference angles equals the angle given minus 180, and again, notice the reference angle is 30 degrees. And if my terminal side ends in quadrant 4, I find the reference angle by doing 360 minus the angle given, which our example was 330, and that equals 30 degrees. So again, you can kind of figure out the formula. I prefer to draw it. You can do it either way, but you're going to want to have that reference angle, and we're going to use that reference angle along with what we know about 30, 60, 90 triangles and 45, 45, 90 triangles, and we're going to identify our sine, cosine, tangent, and all our other trig functions. We're going to ask you these answers to be exact, which means we're not going to want you to punch it into your calculator and find 0.5. What we're going to want you to do in here is to have the 30, 60, 90 triangle written out. You know it's going to be 1, radical 3, and 2. So when I ask you the sine of 30, the exact answer is opposite over hypotenuse, and this is the answer we want, not 0.5, okay? And so you're going to have to use the 1, the 2, the radical 3, and then for 45, 45, 90, the 1, 1, and radical 2, okay? And then lastly, you're going to have to know your signs of those. If you notice, we had 2 positive and we had 2 negative for these. And again, it makes sense because remember that we taught you all students take calculus. And that means that if the reference angle or the original angle, right, all of these have a reference angle of 30, but we have to see where the original angle fell. If the terminal side is in quadrant 1, you know that sine is positive, okay? If the terminal side ends in quadrant 2, again, you know that in quadrant 2, the sine is positive. That's why both of those are positive. Now notice that 210 degrees ends in quadrant 3, and only the tangent and cotangent are positive in quadrant 3. So that's why we have a negative sign here, okay? And then this one, again, the last one, 330, ends in quadrant 4, and only the cosine is positive, and it's reciprocal, the secant. So we know that the sine is going to be negative in quadrant 4. So again, you have to find the reference angle and know Once you're done, check to see if that trig function you're looking for is positive or negative in that quadrant. So let's do some problems and you'll see kind of how to do it. So we come over to here to these examples and notice they're asking us sine and tangent, and cosine. So again, trig functions, we have these degrees, and again, we want to identify the proper reference angle that goes with them. And then once we identify the reference angle, then we can start figuring out our values. So for me, I always have handy on my paper in this assessment and any one where I'm going to be doing trig function, especially with special right triangles, I think it's super important that somewhere on your page you have the 30, 60, 90 and you have the correct values written and you have your 45, 45 triangle as well, and you have the correct values written for those as well. So 1, 1, and radical 2. That's going to be quite helpful. The other thing you're probably going to want to have written somewhere on your paper is your coordinate plane where you have all students take calculus to remind yourself of what's positive in what quadrant. And then for each of these problems, again, I would consider drawing them out. Okay, so for number 6, I come over to here and I draw my coordinate plane, and I'm going to find that angle 210. I know 210 is going to go 180 and an additional 30. So I know it's going to be something like that. So my reference angle is going to be this 30 degrees because this is 210 degrees is 30 degrees below the x-axis. So I know my reference angle is 30. I know this is 90 and this will be 60. And so now I'm able to kind of create this right triangle. So my reference angle is going to be 30. So this is going to be sine of 210 is going to be, let me kind of write it like this. The sine of 210 is going to be equal to the sine of 30 degrees. Okay, so now let's work on the sine of 30. The side opposite the 30 is 1. This one is radical 3. And the hypotenuse is 2. And what I need to think about here now is the quadrant that it's in. This is in quadrant 3. And in quadrant 3, I know that my x is negative and my y is negative. So I do have to kind of add the negatives to this. Now I'm ready to find my sine. I know my sine is opposite. I'll do it over here. My sine is going to equal opposite, which is going to be -1, over hypotenuse, which is 2. So I know that my answer here is -1/2. And this is an exact answer, which is really important, okay? This is what we want when we say exact. We don't want your calculator version of 0.5 or anything else, okay? So that's how we do it, and you double check. Should the sine be negative in quadrant 3? Yes, it should be. Only the tangent is positive in quadrant 3, and it's reciprocal, the cotangent. So now we go to the second question, and we do the same thing. We have tangent of 300. So again, I draw my coordinate plane. I'm going to identify this angle. I know that I go 180, another 90 is 270, and I'm going to go 30 more here to this angle, which is 300 degrees, right? Now, I'm going to draw my triangle from here, and I recognize that the distance, the degree between the terminal side and the x-axis, I know is 60. So let me just do that a little neater, right? So I know that this is 60. It's 60 degrees from the terminal side over to the x-axis. So again, this is a 30, 60, 90 triangle here. And I know that my opposite the 30 is 1. The opposite the 60 is square root of 3. And my hypotenuse is 2. So I kind of have my triangle now that I'm going to work with. Last thing, let me think of the quadrant. I know x is positive and y is going to be negative. Okay, so I'm going to have a negative radical 3 on that side. So again, tangent of 300 is going to be equal to tangent of 60 degrees, its reference angle. So if I ask you for the reference angle, it's 60 degrees. And the tangent of 60 degrees in this problem is going to be opposite, which is negative radical 3, over adjacent, which is 1. So I know the tangent of 60 degrees is going to equal, or the tangent of this, I'll just do it over here, is negative radical 3. Okay, and so again, that's how we do it. And again, I ask myself, should my tangent be negative in quadrant 4? Yes, the only thing that's positive in quadrant 4 is the cosine, and it's reciprocal to secant. And that's how we solve these problems. So again, let's keep going. I'm going to go here to my coordinate plane. Now here, I could do a revolution and keep going, but I'd rather just find a coterminal angle. I know that if I subtract 360, right, from 675, I'm going to get 315 degrees. So I know that tangent of 675 is going to be the same as the tangent of 315 degrees. So let me graph 315 degrees to start. So again, I'm going to start here, and I'm going to go 180, 270, and 270 plus 45 is going to get me here to 315 degrees. And I notice that from here to here, I've got 45 degrees left. And so my reference angle is going to be the tangent of 45 degrees, okay? So I'm going to create my triangle. So this is also 45. And I know that it's going to be 1, 1, and radical 2. Now, because I'm in quadrant 4, again, I know my x is positive and my y is negative. So the tangent of 45 degrees is going to be opposite, negative 1. Like let's say that here's my 45 that I'm looking at. Opposite is negative 1 and adjacent is positive 1. And so my answer is negative 1. So, you know, tangent of 45, if a quadrant wasn't involved, is just going to be positive 1. But in this problem, because we're in quadrant 4, I have to make sure that I apply that negative in there. Okay? So again, think of it this way. Tangent of 675, which is the same as the tangent of 315, is going to be negative 1. And then we'll go to our last problem. Again, we do the same thing. This one's a negative angle, so I have to be careful on that. And it's 240 degrees. So again, I'm going to go in the negative direction. This is 180. And 180 and 60 more is going to take me to 240. So negative 240 ends on this terminal side here, right? That's the big angle. You know, I always start in my standard position. And now I have to figure out, well, how many degrees away is this from this x-axis? And I know that it's 60 degrees away. So what I've created here is a 30, 60, 90 triangle, okay? And again, you know it's 1, radical 3, and 2. And so now I have to find this. So my cosine of negative 240 is going to be equal to the cosine of the reference angle, 60 degrees. And the cosine of 60 degrees is going to be adjacent, which is going to be 1. Oh, well, first of all, sorry, let me think of negative and positive, right? I know the x is negative in this quadrant and the y is positive in this quadrant. So when I go to do my ratios and I go to do adjacent, it's negative 1. And when I go to do adjacent over hypotenuse, it's going to be the hypotenuse is 2. And so the exact cosine of negative 240 degrees is going to match the cosine of 60, which is a half. And because it's in that second quadrant, I know that in the second quadrant, only the sine and cosecant are positive. So negative is right. And so again, it takes a little bit of skill, right? You have to, number 1, draw the angles correctly. Number 2, find the reference angle correctly. You know, do your 30, 60, 90 or your 45, 45, 90. These values have to be correct, right? We know we have to do these right. And then lastly, you have to remember the quadrant and which is positive and which is negative. So there's lots of little skills involved in this to be successful. But again, in the end, it's pretty basic. I know the tangent. Right, so we're going to keep going and we're going to do 5 more here. And again, same concept. So I'm going to keep drawing those things that I think are super important for you to have on this page. And again, I think it's really important that you have all students take calculus so you know which ones are positive. And again, I think it's really important that you draw out a 30, 60, 90 triangle and have your values listed, okay? So again, here's my 45, 45, 90. This is just a good reminder for you so you don't forget when you get bogged down with the problem. And then again, you're just going to draw your angle first. So I have 210 degrees. I know 210 degrees is going to go 180 plus an additional 30. This is 210. So again, I know that my reference angle is going to be 30 because it's 30 degrees away from 180, which is the x-axis. So 30, 60, 90. And again, opposite 30 is 1. Opposite the 60 is radical 3. The hypotenuse is 2. I think about negatives and positives. I know that if I'm in quadrant 3, the x is negative and the y is negative. The hypotenuse is always positive. So now I'm going to try to find it. Now for secant, you can just know, like we know that cosine equals adjacent over hypotenuse, which means the secant is going to be the hypotenuse over the adjacent. So you can do it that way, okay? So I know secant of 210 is going to be the same as the secant of its reference angle, which is 30 degrees. And so again, I'm going to be doing the hypotenuse, which in this case is 2, and the adjacent, which is negative radical 3. And then again, I have to obviously rationalize this radical. So my answer is going to be, when I rationalize that, it's going to be 2 radical 3 over 3, and it's going to be negative. And I double check again, cosine and secant are both going to be negative in quadrant 3. So I know that's the right answer. And that's the strategy. So again, cotangent here. Again, let me kind of go. I know that I'm going to draw my angle first, just to get started. Again, I come over to here. It's 135 degrees, so that's 90 plus 45. So I know this is 135 degrees, which means this reference angle is 45 degrees. And so again, I'm going to draw a 45, 45, 90. And I know this is 1, 1, and square root of 2. And again, in quadrant 3, I know the x is negative and the y is positive. So I'm looking good here. So the cotangent of 135 is going to be the same as the cotangent of the reference angle, which is 45 degrees. I know that tangent is opposite over adjacent. So I know that means cotangent is going to be adjacent over opposite. So let's do that, right? So cotangent of 45 is going to be adjacent, which is negative 1, over opposite, which is 1. So negative 1. So my answer is negative 1. Okay? Remember, in a 45, 45, 90 triangle, tangent and cotangent are always 1. Depending on the quadrant, it'll be positive or negative. Eventually, you'll get to the point where once you see the reference angle's 45, you don't even really have to draw it out. You know it's 1. You just have to figure out the quadrant and is it positive or negative. But so anyway, so here we've got that. Because it's in quadrant 1, sorry, I think I got cut off. Because it's in quadrant 1, I know that the tangent, or in quadrant 2 rather, I know the tangent is negative in this quadrant, so I know my answer is negative 1. Okay, we keep going. I go to number 12. Now 12 is 210. It's the cosecant of 210. And notice in 10, I use 210 as well. So this graph, the blue graph, all of those numbers are the same for number 12. So instead of redrawing it, I'm just going to use that drawing. Now I know that cosecant, remember, is the reciprocal of sine. Sine is opposite over hypotenuse, and so the cosecant would be hypotenuse over opposite. So my reference angle for the cosecant of 210 is going to be the cosecant of 30 degrees. And when I go to that drawing, I know that the opposite is negative 1, and I know that the hypotenuse is 2. So 2 over negative 1 is going to be negative 2. And so the cosecant is negative 2. Okay? And again, I know that sine and cosecant are negative in the third quadrant, and that makes sense. Okay? So keep going. Let's do number 13. I've got again here, I've got my graph. Now I have here negative 510, and I know that's more than one rotation. Anything greater than 360 or less than negative 360 is going to be more than one rotation. So I'm going to use the skill we learned earlier about coterminal angles. And I know that a coterminal angle, now this is not a reference angle, but a coterminal angle with negative 510 is if I add 360 to this, I'm going to find a coterminal angle, and it should be negative 150. So I know that the sine of negative 150 is going to be the same. Like 150, negative 150 and negative 510 are coterminal, okay? So now that I know they're coterminal, they end in the same spot, I'm ready to do my graph. Now just to confirm that, you'll see, right, if I do negative 360, it's one lap, and then 360 and 90 is 450, right? Yep, 450. And then 450 and 50 is 500, and 10 more, so 60 is here. Now, let's just do negative 150 and see if I end in the same spot. Negative 90 and 60 more gets me to 150, and so it's coterminal. So what I don't have to do is this whole revolution part here, right? I can end in the same spot. So let me just kind of draw it now better with that negative 150. Now I can find my reference angle, okay? So again, negative 150 is going to be here, and that's going to be 30 degrees away from the x-axis. So I know that what I've got is this 30, 60, 90 triangle here, 1, radical 3, and 2. And so I know that the reference angle for negative 510 is going to be 30 degrees. So if I can find the sine of 30 degrees, I can find the sine of negative 510. So the sine, again, is going to be opposite over hypotenuse. And again, before I do that, let me just put my negatives in here. I know this is third quadrant, both things are negative. And so I know opposite is negative 1, hypotenuse is 2. And so this answer is negative 1/2. Okay? And last but not least on this page, let's do, sorry, let me do that. Let's draw this one. So again here, I'm going to draw this graph here, right? And before I start doing all these rotations, I know that the tangent of negative 120 has to have a coterminal angle to it. And basically, I just take negative 1020 on my calculator and just keep adding 360 to it until you get it to some kind of a positive value. And because you have your calculator, this is easy. A coterminal angle to this would be negative 300 degrees. And so that's what we're going to draw. So the tangent of negative 300 is going to be the same. It's coterminal. Let's see where that ends up so I can find my reference angle. So again, I'm here. I'm going to do all the way to here I know is 270, and an extra 30 gets me to negative 300. And so I know that this angle here is going to be 60. So if I just draw this right triangle, I know that I'm going to get a 30, 60, 90. I know this is 1, this is radical 3, and this is 2. It's in quadrant 1, so everything is positive, which is great. And I know that my reference angle then is going to be tangent of 60 degrees. And then I know it's going to be opposite over adjacent. Oops, radical 3 over 1. So it's radical 3. And it's going to be positive because, again, it is in that first quadrant, which is all the values are positive in that quadrant. Again, you just keep referring back to your chart. So we're going to find the angle when given the trig functions, and this one's a little bit difficult. Just remember that in this case and in these cases, you're always going to be dealing with either a 30, 60, 90 triangle. Again, you know these values, okay? And a 45, 45, 90 triangle. Okay, these are the ones we're going to be giving you. We're not giving you any other ones for this kind of problem. And so when you look at the problem and it tells you, like, we want you to find the angle when the cosine of theta, we want you to find theta when the cosine equals negative radical 2 over 2. So the negative is important because cosine is only positive in 2 quadrants and it's negative in 2 quadrants. And so again, that's kind of important. That's going to give us an indication of what quadrant we're in. And then you also want to pay attention to the values. When you see a radical 2, you know you're dealing with this type of triangle. If you see a radical 3, you know you're dealing with a 30, 60, 90. So in this problem, I know I'm dealing with a reference angle, degrees that have a reference angle of 45. Okay. And I know that my quadrant, if my cosine is negative, and if I do my, all students take calculus, I know that to have a negative cosine, calculus, let's see. I know that if I have to have a negative cosine, well, my cosine is positive in the first and fourth quadrant, so it's got to be in the second and third. So we're going to come over to here, and we're going to start, and we're going to look at the second quadrant first. We'll start there. I know that my reference angle has to be 45. So I'm going to have a 45, 45, 90. It's 1, 1, and radical 2. Now, again, because I'm in this second quadrant, my x is negative and my y is positive. So I know the cosine of 45 in quadrant 2, right, is going to equal adjacent, which is negative 1, over hypotenuse, which is radical 2. And if I rationalize this denominator, notice what I end up getting, negative radical 2 over 2. So that equals this. So I know that to have a cosine of here, this reference angle is going to go with the angle that's going to give me that. Well, what angle gives me this? Well, I start here, and I go this way, and I know that this angle is 180 minus 45, or 135 degree. So remember, you're working backwards. A positive 135 degree angle will give me a reference angle of 45, and that reference angle of 45 will give me this cosine of negative radical 2 over 2. So one angle measure for theta is that theta equals positive 135 degrees. Now this is where this interval matters, guys, because I know that there are other angles that are coterminal with this. In fact, if I do negative 225 degrees, that's also going to give me the same cosine, but negative 225 degrees is not in my range, okay? So again, the range just wants positive degrees and in one rotation. It doesn't want any negative degrees that have that answer, and it doesn't want any positive degrees beyond 360, because again, we all know that if I take 135 and I add 360 to it, I'm going to have another coterminal angle, which is going to also have this cosine. And so again, there's an infinite number, but that's why the range limits us, okay? So let me kind of erase all this extra stuff here. Let me erase this negative stuff. We didn't need that, okay? And so again, now I have my 135 degree angle in quadrant 2. Well, again, I want to know, are there any more? I know that I could potentially have a negative answer, a negative cosine in quadrant 3 as well. So let me do the same thing. Let me find an angle that'll put me in quadrant 3. So if I come around like this, it's 180. 180 plus 45 is going to take me here to 225 degrees. That is going to give me a 45 degree reference angle here. And so again, let me kind of create this triangle, right? I'm going to erase out the other one just because it's kind of just bothering me here, right? Let's erase the 135. We already know that one. So again, if I do to here, I know that that's 225 degrees, and that has a reference angle of 45. So again, 45, 45, 90. And I know that, again, this here is going to be negative 1. This is negative 1. And this is radical 2. So now let's see what my reference angle would be here. If I do my reference angles, okay, cosine of 45, I look here, my adjacent is negative 1, and my hypotenuse is radical 2 again. And when I simplify, notice that again, I get negative radical 2 over 2. And so this degree measure of theta equals 225 these two values give me this cosine, okay? And so that's the answer to this question. Had I started and asked you for what is the cosine of 225 or what is the cosine of 135, you would have worked it the other way like you've been doing, and you would have told me negative radical 2 over 2. Now we're just going backwards. Both of these values are in the range, and so I know this is correct. So we're going to do a few more problems of that kind. And again, as always, I highly suggest you have, this is not going to be given to you on the test, so as soon as you get your assessment, I highly recommend that you write this out, okay? And again, your 45, 45, 90. Oops, it's terrible. 45, 45, 1, 1, radical 2. And again, know that your quadrants, where they're positive, all students take calculus, okay? So again, I'm going to go to cosine theta, and notice the question. It has a radical 3 in it. So I know this is going to relate to the 30, 60, 90 triangle there. And I see that, cosine, remember that cosine is adjacent over hypotenuse. So I look at which angle, 30 or 60, has an adjacent side of radical 3. And I notice that it's the 30 degrees. The adjacent is radical 3 and the hypotenuse is 2. So I know that what I'm looking for here, my reference angle, is going to be 30 degrees. So I'm going to come over to my drawing, and I'm going to just kind of double check here. I'm going to do 30 degrees here. Again, I've got 1, I've got radical 3 and 2, right? And so I know adjacent radical 3, and again, this is negative, and the hypotenuse is always positive. So let's just make sure, right? Cosine of 30 degrees equals adjacent over hypotenuse. It matches. So what angle gives me this 30-degree reference angle? Well, again, here, it's going to be 150 degrees. So I know that one value for theta is 150 degrees. And now I'm going to do the same thing, but I'm going to do it in the other quadrant. So again, I kind of erase this. I know 150 gives me what I need, right? And I'm going to go again in quadrant 3. So again, I think, okay, my reference angle is going to have to be 30 here, 30 and 60, right? This is going to be negative radical 3 and 2 again. And again, what angle is going to give me this? Well, again, it's 180 plus 30 is going to give me this. So 180 plus 30 is 210. So I know 210 degrees will also give me a cosine. It'll have to be a 210 will give me a reference angle of 30, and 30 will give me a cosine of negative radical 3 over 2. And so those are my 2 degrees that work. And they fall again in that range. It's the same problem as the slide before, okay, where it was negative. And it's negative here and here, okay? It's positive in here and here, which doesn't work, okay? Okay, so now we go to the tangent question. And again, it's tangent theta equals negative 3, or we can say negative radical 3 over 1. Now, when I see radical 3 again, I'm thinking 30, 60, 90, right? And I know that tangent is opposite over adjacent. So if I come over to here, and I'm going to draw this out, right? I got to think which angle, first of all, if I look just here, which angle in a 30, 60, 90 has an opposite of radical 3 and an adjacent of 1. And you see that it's the 60 degrees. So I know that I'm dealing with 60 degrees for my reference angle, okay? So now I have to figure out, okay, what quadrant am I in? My tangent is negative. Well, my tangent's positive in first and third, so it's going to have to be quadrant 2 and quadrant 4. So I come over to my drawing, and I go to quadrant 2, and I make myself a 60-degree triangle, reference angle. This is 30. Again, remember, this is 1, this is radical 3, and this is 2. And I know the tangent of 60, again, would be opposite, right? Radical 3 over adjacent. Remember, this is positive here, this one's negative. And so I know that that works. So what angle between 0 and 360 gives me this reference angle here? Well, it's going to be this angle, which is 120. So I know that theta has to be 120 degrees to get that answer. And if I repeat and I do the same thing for quadrant 4, which is the other location where I know the tangent can be negative, I've got to ask myself, well, what angle is going to give me a reference angle in quadrant 4 of 60 degrees, right? Because again, I'm going to need this. This is radical 3. This is negative radical 3. This is 1 and this is 2. Again, opposite over adjacent is going to be negative 3 over 1. It works. Well, what angle gives me that? Well, again, I start here. I've got 180, 270, and 30 more is 300. So I know that theta is also 300 degrees. Both of these angles are between 0 and 360 degrees. Both of these angles will give me a reference angle of 60 here and here. And both of these angles, when I do the math, the cosine will be opposite negative radical 3 over 1 adjacent. Okay, it's going to give me that negative answer. So that's the answer they're looking for. So again, I go to cosecant. Here it tells me that the cosecant is both positive and negative. So this is all 4 quadrants, if you think about it, okay? Because I know that the cosecant goes with the sine, and the sine is positive in quadrants 1 and 2, and it's negative in quadrants 3 and 4. And so I know that this answer is going to look for 4 values. So because I see a radical 3 in it, I know that it's going to go with the 30, 60, 90 triangle as well. So I have to sort of think about what might this have started out being, right? So when I see that radical at the top and not at the bottom, I know that this was probably a fraction that started out being with a radical in the bottom, and we rationalized it. So I know, and you're going to get used to this as you do enough of this, I know that what's going to happen here is that this was probably 2 over radical 3 to start with. That would make sense, right? If I rationalize this, notice that I end up getting 2 radical 3 over 3. And so this started like this, okay? And so cosecant is the reciprocal of the sine. Sine is opposite over hypotenuse, so this would be hypotenuse over opposite. So the hypotenuse here is 2, and the opposite is radical 3. So again, what angle in a 30, 60, 90 triangle has a hypotenuse of 2 and an opposite of 3? And when I go to this, I know that it's 60, right? So again, my reference angle is 60. So I'm going to need to know the angle in a triangle that gives me a reference angle of 60 every time. Well, in quadrant 1, remember the reference angle is just the angle. So 60 degrees is one answer for theta. In quadrant 2, if I give myself a reference angle of 60, I know the angle that goes with that is 120 degrees, okay? In quadrant 3, if I have a reference angle of 60 degrees, I know the angle that goes with that is 180 plus 60, or 240, okay? And in quadrant 4, I know the angle that gives me a reference angle of 60 is going to be, again, I start here and I go all the way to here, and that's going to be 300. So I know that 300 is the one that I'm looking for there. And so those are the 4 values of theta, okay? So again, if I had given you, find the reference angle or find the cosecant of 120 degrees, you would have done exactly what we did here, just backwards. You would have drawn the 120 degrees. You would have identified this reference angle 60. You would have drawn your triangle, radical 3, 1, and 2, knowing that this, this one here was negative, let's say, and because you were looking for cosecant, you would have done the hypotenuse, which was 2, over the opposite, which was radical 3, and you would have gotten this answer, okay? And then you would have had to rationalize it. So again, you don't have to do each individual one. Once you learn the pattern and you know the quadrants, that's easy to identify the reference angles. The important thing is just figuring out which reference angle is going to give you that initial value, and then you can go from there. Okay, so again, the last one we get tangent of theta is radical 3 over 3. And once again, because you see that radical 3, you know it's this, okay? And again, you see the radical in the top. And so again, you know that the tangent is opposite over adjacent. However, if you just think about it, none of these opposites over adjacent will give you, you know, a 3 in the bottom. So this ended up being something that was rationalized. So really the tangent, without rationalizing it, this was going to be 1 over radical 3. Once you rationalize it, it gets to that. And so you realize that your opposite here is 1, and your adjacent for this problem is radical 3. And then you're like, okay, I know this. It's positive. What quadrant is your tangent positive in? Well, I'm going to fix this here. It's a positive answer. Your tangent is always positive in quadrant 1, as is everything else, and in quadrant 3. So this answer has to be in quadrant 3 and 1. And then I ask myself, well, what angle, 30 or 60, has an opposite of 1 and an adjacent of radical 3? So again, opposite of 1, adjacent of radical 3, that's the 30-degree mark. So my reference angle for this is going to be 30 degrees. So I'm going to come over here and find all the values, all the degrees that have a reference angle of 30. In quadrant 1, it's 30 degrees, so I know theta is 30. That's one value, right? And I'll double check. Let me just make sure 30 is the right answer, right? I know that this is 1, this is radical 3, and this is 2. And the tangent of 30 equals opposite over adjacent, which equals radical 3 over 3. And notice it's right. So I know 30 is the correct reference angle. Now I just need to find the other value where 30 gives me that same positive radical 3 over 3. And I know that's in quadrant 3. So if I'm in quadrant 3 with a reference angle of 30, I need to know what this degree measure is then. Well, I know that's 180 plus 30, or 210. So 210 is the other theta in the range. If I did a theta in the second quadrant, a reference angle in the second quadrant or the fourth quadrant, my tangent would have been negative. And the question tells me my tangent is positive, so it has to be in those two quadrants. And those are my final two answers. So yes, this is a little challenging. You are working it backwards, but once you find one and you know what your reference angle is, then you can apply it to the proper quadrants.